Okay, and the last part of this chapter is a very small chapter, very easy chapter. And the last part of the chapter is about two populations variances. Okay, so we have what? Two populations. Okay, population number 1 and population number 2. And from this population, I know that I have sigma 1 squared, that is the population parameter. I'm going to get a sample from here, a sample of size n1, and I'm going to get what? The sample variance, and I'm going to have the second population, sigma 2 squared, and from the sample is S2 squared, and N2 is my second sample size. Okay, for this, to compare these variances between the two populations, we need to learn a new probability distribution that is an F distribution. Is if we draw the F distribution, it starts at 0. This is the F distribution, and the F distribution has two parameters. The degrees of freedoms in the numerator, the degrees of freedom with the numerator, and that is n1 minus 1 is the degrees of freedom on the numerator, and the degrees of freedom of the denominator is n2 minus 1 degrees of freedoms. And that's it. Now, if you go to the back of the book where the F distribution is, you're going to see, we're going to need how to read this table. On the top of the table, you're going to find the numerator degrees of freedom. Okay? And in the left side, the first column is the denominator degrees of freedom. So we have to match those row and column. Now, we also have only 0.1, 0.05, 0.025, and 0.01. These four values are the only values that we have in my distribution. So we only have the right tail test. And we are going to learn how to do only the right tail test by comparing the population parameters. Now, if we have S1 squared divided by S2 squared, this follows a F distribution with N1 minus 1 degrees of freedom in the numerator and N2 minus 1 degrees of freedom on the denominator, where N1 is the sample size for the population 1 and N2 is the sample size of the population 2. That's it. Now, how are we going to do that? Okay. Well, we know that. So if this S1 squared divided by S2 squared is or follows a F distribution with n minus 1 degrees of freedom in the numerator and n2 minus 1 degrees of freedom in the denominator. So we can have what? Let's do the hypothesis testing. Frank. The null hypothesis and the alternative hypothesis is that sigma 1 squared is equal to sigma 2 squared against that is not equal. Okay, this is one test. The other one is, the null hypothesis is the sigma 1 squared is what? Is less or equal than sigma 2 squared against that is greater than sigma 2 squared. Okay? And the third hypothesis is the one that we have sigma 1 squared is greater or equal than sigma 2 squared against that is less. Okay? In this case, we would have a left tail test. In this case, we would have a right tail test, and this is alpha. And in this case, we would have a two-tail test. And of course, this is alpha divided by 2, and this is alpha divided by 2. This is alpha, and this is alpha. But what happened in here? Since we do only have the values of the F distribution of the right side, what we are going to do in case that we have this situation is what? We inverse these values and convert it to a upper tail value or upper tail test. Okay, in order to have here the upper tail test for this distribution, we need to be sure that the population 1 is the one that has the highest sample variance. Highest sample variance. The population 1 is the one that have the highest S squared. Why? Because we are going to have an upper tail test, and if we do the p-value, we have to, remember, you can do this using the p-value or the critical value, it really doesn't matter, but when you have a two-tail test, the p-value, the original p-value that you have has to be double, okay? So, basically, but in this case, since we are going to use the tables only, we have to be sure that the population 1 is the one that has the highest variance, sample variance. And that's it. And we are going, and this is the critical values. Okay? But, you know, again, we are going to use only the right side table. And the test value is going to be S1 squared divided by S2 squared. And if this test value is in the rejection zones, we reject the null hypothesis. If it's in the don't reject zone, do not reject the null hypothesis, depending on the hypothesis that we are dealing with. That's it. Let's do a problem. Let's do problem number 14. Okay, and that's it. Pretty easy and pretty simple. This is very easy chapter. Number 14 says, a sample of 16 items from population 1, so N1 is equal to 16, gives a sample variance S1 squared 5.8. Okay. And a sample of 21 items, N2 is equal to 21. And the sample variance for the second population is 2.4. The hypothesis, alpha is equal to 0.05. The hypothesis is sigma 1 squared is what? Less or equal against greater. Okay, so this is what? A one-tail test, an upper tail test. This is alpha, so this has to be 0.05. And that's it. This is the F distribution. Now, what is the critical value over here? We have to go to the F distribution, and we have to look for how many degrees of freedom in the denominator? 50 in the numerator, and how many? 20 in the denominator, okay? And we are going to look for the 0.05. Okay, numerator 15, and denominator 20. Go to the next page. And that is on page 987, around the middle. So you're going to find 15 over here, okay? 15 over here, and go to the 20 over here, okay? And go to 0.05, that is the one that we are looking for. 15 and 20.05, that is 2.20. So this is 2.20. This is my critical value. This is the zone or the value that divides the rejection zone from the non-rejection zone. And we are going to compare that with the test value. What is the test value? S1 squared divided by S2 squared. And that is equal to nothing but 5.8 divided by 2.4. That's it. 5.8 divided by 2.4, and that is equal to 2.42. Where is that? Where is 2.42? Over here, on the rejection zone, because the critical value is 2.2. So we reject. We reject. What we reject? The null hypothesis. So we say that indeed the variance of the population 1 is really higher than the variance from the population 2. And that is the statistical conclusion on this problem. And that's it. That's all about chapter 11.